Okay, in this video we're going to learn how to do algebra on vectors, so basically like adding or taking vectors from each other. If you have these two vectors sitting here, A and B, to add them together, basically what you do is you draw A and then you draw B coming out from the tip of A, and then that kind of line going from the start of A to the end of that B that you've drawn is A plus B. So you can add algebraically or you can add geometrically, and we're going to see both here. Taking is the same, so here if I wanted to do A take B, I'd point B going the other way. And then that line up there would be A take B. So you can also do scalar multiplication. So 2A would kind of be like putting two A's head to tail, and that would double the lengths. And yeah, that's pretty much it. So what we're going to do is draw these two vectors, V and W. So here's 3 and here's 4. That is the vector V there. And we'll do W, well, 1 and minus 2. There's the vector W pointing down there. Doesn't really matter where I drew W. I could have drawn it over here. The point is that is W. All right, great. So what we're going to do is find V plus W. Now, realistically, all you have to do to find V plus W is you can add the components. So this is going to be 3, 4 plus 1 minus 2. Or remember, sometimes you'll see this written as 3, 4 and 1 minus 2. Please be aware you will see both. That's going to be, well, 3 plus 1 is 4, and then 4 take 2 is 2. There's our vector. So I'm claiming that it's 4, 2. So if I draw this line, let's pick another color, black, 4 and 2, I'm claiming that this black line should be V plus W. And we can actually see why this is true. So here's V up here. And if I draw another copy of W, just coming from V down here, there's W. And if I go along V and down W, I'd get to V plus W. It's pretty cool. Okay, so we're going to do V take W. So again, this is going to just be 3, 4, take 1, minus 2. So the resulting vector is 3 take 1 and 4 take minus 2. Because the 2 takes become a plus, that's a 6. So let's have a look and see what we got. Again, I've got the vector V coming out here. And I've got this vector minus W. So that's going to be 1 back and 2 up. And then if I join them up, that should give me the vector V take W, which is 2, 6. So it works algebraically, like with the numbers, and geometrically, like with the pictures. Let's do another one, 2V. All right. So this is going to be 2 lots of this vector V that we've been working with, which is 3, 4, which is going to be 6, 8. And again, I'll show you why this is true. So if I draw V out here, which was at 3, 4, here's one copy of V, and I'm going to draw another copy of V coming straight off that. Here's another copy of V. Now if I go all the way along that vector, that resulting thing that I get is 2V. 2 lots of V. All right, next we're going to find minus 3W. So this is going to be minus 3 times our W vector, which was 1 minus 2. And I believe, let me just make sure W was that, 1 minus 2, yeah. This is going to be minus 3 and positive 6. So here is W. And maybe in another color, here is minus W, it points the other way. So here's another copy of minus W. And here's another copy of minus W. And if you put all 3 of those together, you're going to get minus 3W. And if we look at the points, it's at minus 3 and it's at 6. How cool is that? Last one I'm going to do is 2V plus 3W. So that's going to be 2 lots of 3, 4 plus 3 lots of, now W was 1 with minus 2. So that's going to be 6, 8 plus 3 minus 6. So that's going to be 6 and 3 give you 9, and then 8 take 6 gives you 2. So let's see. Here's a copy of V. It's at 3 and 4. there's V. I'm then going to go up another V. So now I'm at 2V. And then I'm going to go down a few W's. So there's a W. There's another W. There's another W. And if I look at the resulting vector that I get there, that's going to be 2V plus 3W. You can see that it is at 9 and it is at 2. That point right there.